Here's the seating chart, and then I starred the ones that have IEPs, so you kind of have an idea.
No, thank you.
I don't always do that, but I should remember this time.
Thanks.
Okay, so we're going to start notes today. Like I said yesterday, we are going to do this a little different. We're going to do sections, and then after each section, I'm going to give you time to work on the homework, so you kind of get it done. You won't be able to get it done. So you don't have any homework you have to take outside of class. Okay, so let's look at this. If you had me last semester, these it might look the same, but these are going to be different notes, so you still need to write them down. It's going to be different stuff than last semester, so don't think it's all the same, because it's not. Same content, just different notes and stuff. So what we're going to do today is we are going to look at classifying numbers. So I'm going to give you numbers, and I'm going to say classify these using these categories. So let's go ahead and look at this mapping, and this mapping will help you categorize these numbers. First of all, we have real numbers, which we represent with R. So we can use the abbreviations to help us, and those are all numbers. So every number that you have talked about up to this point is considered a real number. So like I said yesterday, you need to make sure you're getting these notes down. I will be checking these before we take the test over this unit to make sure you have these. So write down what I'm writing down. We're not going to take notes every day, and we're not going to take a ton of notes. So what I write down, I want you to write down too. So we're going to start with the top of the map. A real number is any number we've talked about. Any number that you know up to this point is a real number. And then we can split it into two categories, either irrational or rational number. So if you look at irrational, if you read it, those are decimals that never end and have no pattern. Think mumbo-jumbo numbers. So an irrational number is a number that's a decimal that never ends and have no pattern. So an example would be what? Do what? Pi. So pi is a perfect example. Anything with pi is irrational. 3.14 blah, 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 blah. So whether it's pi or pi over 3 or 4 pi, anything with pi is always irrational. So that's one thing. Irrational is also non-perfect square roots. So I should have told you to grab a calculator. If you don't have a calculator, grab one real quick from the front. So make sure you grab one because I want you guys to do this. This is the easiest way to tell if something is irrational or not. A square root is irrational. Okay, so jot down real quick underneath irrational. Irrational numbers are pi and non-perfect square roots. So math has lingo, and I'm going to do my best to kind of decipher that lingo for you. So anything with pi and non-perfect square roots. So what would be a perfect square root? So what number is a perfect square? I remember. Perfect squares are numbers that you can take the square root of and it comes out as an even number. So what number would be a perfect square? 4 or square root of 6 is not even number. 20. Nope, 5. So 4, 9, 16, 25, 36. You don't have to have them memorized. The shortcut to tell whether a number is a perfect square or not is plug it in your calculator. So if I have the square root, let's say I have the square root of 35. Okay? Not all square roots are irrational. It is only irrational if it is a non-perfect square root. How to tell whether it's a non-perfect square root? Plug it in your calculator. So to plug in your calculator, the square root button is above the x squared. So you're going to press the green second button and then press the x squared button and you will get the square root. So second button up at the top left, and then the x squared will get you the square root. So if I want to know if the square root of 35 is a perfect square or not, do square root of 35. If it comes out as a decimal, it is not a perfect square. So any non-perfect square is irrational. So the square root of 35, 35 is not a perfect square. When I plug it in, I get a decimal, so this is irrational. So just because it's a square root does not mean it's irrational. It has to be a non-perfect square. So square root of 35 or negative square root of 15. So square root of non-perfect squares are irrational. So be careful of square root. Just because this is square root does not make it irrational. We'll look at some example. So irrational numbers. Pi, non-perfect square roots, decimals that don't end or don't have a pattern. Irrational is another option. So it's either irrational or rational. Rational is another option. Rational are all fractions and decimals that end or have a pattern. We represent rational with Q, which is kind of weird. But what word do I see in rational? Ration. Yeah, ratio. So if I think of a ratio or even a ration, and you split stuff up, if I think of a ratio, ratio is a fancy math word that basically means what? I remember? A fraction. So a ratio is basically the same thing as a fraction. So if you see rational, we think a fraction. Now what operation does the fraction bar represent? Operation is add, subtract, multiply, divide. Divide. And what's the name for division problem? What word do we have that is the answer to a division problem? Quotient. That's where the Q comes from. That's the way to remember. So rational, think fraction. Fraction is dividing. Dividing is quotient. Okay, you won't have to have these memorized. Just be able to use them. These are all fractions. So any fraction is a rational number. So 1/3, -5 1/4. Any fraction. How about a whole number? If I just had 5, is 5 a fraction? No. Can I write it as a fraction though? Yeah. Yes. How can I write 5 as a fraction? Over 1. So any number like this you can put over 1, so it is a rational number. How about 0? Can I write 0 as a fraction? No. Think about it. Will something divided by something give me 0? No. Yes, the answer is yes. How can I write 0 as a fraction? You can't divide by 0. But where can I put 0 in a fraction to give me 0? 0 divided by what gives me 0? 0. No. 0 divided by anything. If I have 0 over 2 or 0 divided by 3.
0 divided by anything gives me 0. So 0 is rational because I can put it over any number and that will give me 0. Put your head down for me, Elijah, please. Thank you. 0 is rational. It's also a decimal that ends or have a pattern. So -2.153. That decimal ends, so it is rational. How would I represent a decimal that has a pattern? How do I represent a pattern or repeating in fraction or decimal? Yeah, the dash above it. So 3.56, that has a pattern. It has the repeating bar, so that means it's going to be 3.56565656. It has a pattern. It is rational. Okay, any questions on rational? Now, rational, we have another subcategory. We can take rational and see if it's an integer. So integer we represent with a z, which is weird. That's the weird one. Integer is numbers are rational numbers. So every integer is a rational number without, so no decimal or fraction. So we are breaking rational numbers up further. So make sure you kind of write down these notes on the side. So an integer is a rational number that does not have a decimal or fraction. So what would be an integer? Do what? 5. So any number, -2, -1, 0, 1, 2, 3, 4, 5. Any rational number that does not have a decimal or fraction is an integer. We can take it one step further and say, what integers are whole numbers? We represent whole numbers with a W. Whole numbers are integers that have one characteristic. Whole numbers have no negative. They are integers without the negatives. So whole numbers are non-negative integers. So whole numbers are integers but are not negative. So what would be whole numbers? They're the non-negative integers. Don't forget 0. 0, 1, 2, 3, 4, so on. So a whole number is an integer, has the same characteristics, except you cannot have a negative number. And then a natural number, Rn, we represent with n, and those are whole numbers that do not have, if you had to guess, whole numbers without the what? No zero. Yep. So we are just kind of breaking it down further and further into kind of more specific categories. Rational, integer, then whole, and then a natural are whole numbers without the zero. So 1, 2, 3, 4, 5. Okay. So we're just kind of breaking it into separate categories. Any questions on that? Okay, let me do a couple examples on the bottom, then I'm going to have you start the homework, and I'll finish the notes later. Okay, let's look at these examples. Name all sets of numbers in which each number belongs. So let's look at 1. So you're going to look at the map. I think the map is kind of easier to understand than just kind of going through the definitions. Look at the map and kind of start and kind of work your way down. So any number I know is what? R is real. So you always start with R. Start at the top. Now, if you want to write them out, I don't care. If you want to waste your time, I don't care. But you can use the abbreviation, that's fine. Now we go down the map. So once we know it's R, every number is a real number, I have to choose between irrational or rational. Is 30 irrational or rational? Rational, because I can write it as a fraction. How can I write 30 as a fraction? 30 over 1. So it is rational, so I put a Q. So then I have to work down. If it's rational, it could be an integer. An integer are rational numbers that do not have a what? Okay, does 30 have a decimal or fraction? No, so it is an integer. So you put a Z. You keep working your way down. Is it a whole number? Whole numbers are integers that are not negative. It is an integer, or it's a whole number, because it is not negative. And then is it natural? Is it a natural number? Natural number is no zero. Yes, it is not zero, so it is a natural number. She is going through and listing the ones that it fits into. Elijah.
Sorry.
You're fine, yeah. Okay. Okay, let's look at 3. Yes, sir.
How is it not a natural? Like, how is it a natural?
A natural are whole numbers without the zero. So any whole number besides 0 is a natural number. Does that make sense? Okay. Feel free to interrupt me whenever. That's fine. Answer a question. Get an answer now besides waiting and figuring not knowing how to do it. Okay, let's look at 3 real quick. Let's look at 3. 5 and 4/7. I know it's a real number, so I put an R. Then I have to decide, is it irrational or rational? Okay. Why is it rational? Look at kind of what we have when we describe rational. It's a fraction. Any fraction is rational, so I put a Q. Next one is an integer. Is this an integer? No, why not? It's a fraction, so you're done. Once you hit one that doesn't work, you don't have to go further. So it's just real, rational. Let's look at 4. If I look at 4, square root of 21. I know it's real, and then I have to decide between irrational and rational. Now, not every square root is irrational. How do I tell whether a square root is irrational or rational? Yeah, plug it in. Is 21 a perfect square? Where if you don't know off the top of your head, which was kind of obvious at the beginning, a lot of you didn't, which is fine, plug it in your calculator. Square root of 21, if it comes out as a decimal, then it is irrational. It's non-perfect. So square root of 21 does not come out as an even number, so it is irrational, so I put an I. If it's irrational, you don't have to go any further. There's nothing underneath it. So it is real, it is irrational. Okay, let's look at 0. I'll look at 0 real quick. I know it's real. Is 0 irrational or rational? Rational, because I can put it over any number. I can write it as a fraction. Is it an integer? Yes. No decimal or fraction. Is it a whole number? Yes. Is it a natural number? No, because natural numbers do not have 0. Let's look at 6. Even though it's a square root, be careful. What is the square root of 9? Negative 3. Square root of 9 is 3. So if it's a perfect square, plug it in, and if it will come out a whole number, then we can use negative 3. So is negative 3, I know it's going to be real, so you can just rewrite it if you want to and go from there. Is it irrational or rational? Yeah, it simplifies to a whole number, to 3, so it's rational, so I put a Q. Is it an integer? Is negative 3 an integer? Yes, there's no fraction or decimal, so I put a Z. Is it a whole number? No, because whole numbers cannot be negative. So since it's a negative 3, it's not a whole number. So you're done. Let's look at 7 real quick. Check your fractions. See if you can reduce it. Can I reduce 6 over 3? The fraction 6 over 3. What's it reduced to? 2. So divide it out. Remember, fraction is division. So if you can divide out a fraction, divide it out. And you can go through and classify 2, which I'm not going to do because we don't like it. But check your fractions and see if it reduces. 5.3 repeating. Let's look at number 9 real quick. 5.3 repeating. I know it's real. Is it irrational or rational? Do what? Rational, because why? It has a pattern. 0.33333. It's repeating. Any repeating is rational. Is it an integer? No, because it has a decimal part. So it's just real, rational. Okay, any questions on that? Keep that to the side. We're going to finish a couple more notes in a second. But I'm going to let you get started on the homework. Grab the lights for me, please. Okay, do what? Keep them to the side. We're going to finish the back. Here's the homework. So we're going to do a little different. Like I said yesterday, I don't want you to have any homework because this is due by the end of the block. First block was able to get it done. So how we're going to do it, because you don't like taking notes for super long. I don't like teaching for super long.